Hey everyone, and welcome to this deep dive,
Oh, this will be fun.
where we're diving headfirst into faster-than-light travel.
One of my favorite topics.
We've got a mountain of research to dig through.
Yeah, papers, concepts, historical experiments.
Even a little sci-fi for inspiration, you know?
I love some sci-fi.
But we all know the basics here.
I think we can skip those.
Yeah, so let's jump right into the good stuff.
Sounds good.
Can we actually break the cosmic speed limit? That's what we're here to find out.
Well, it's a challenge for sure. Einstein's theory of relativity says nothing can travel faster than light.
Right, but you said locally.
I did.
So is there a loophole there?
There might be, and that's what makes this so interesting.
Okay, I'm intrigued.
Have you ever heard of tachyons?
Tachyons, yeah, hypothetical particles that always travel faster than light.
Exactly, and while we haven't actually observed them,
Right.
they could help explain why that word locally is so important to Einstein's theory.
Okay, so maybe tachyons are a clue.
Maybe.
What else is there? Well, back in 1968, physicist Gerald Feinberg,
Did a lot of work on tachyons.
right, he wrote about their potential connection to negative energy states.
Negative energy states.
Yeah, that concept's going to pop up again later on because some scientists believe negative energy
Okay,
could be the key to unlocking FTL travel.
got it. Negative energy noted.
Okay,
Let's move on to something a little more tangible.
sure.
Like, have there been any real attempts to crack this FTL nut?
Yeah,
What about warp drives?
warp drives now, those capture the imagination, don't they?
You do every sci-fi fan's dream.
And they're not entirely science fiction.
Really?
Yeah. In 1994, a physicist named Miguel Alcubierre,
I've heard that name.
he proposed a theoretical model for a warp drive
Okay.
based on manipulating space-time itself.
So less Star Trek and more like bending the universe to our will.
Exactly. Imagine a spacecraft surrounded by a warp bubble.
Okay. A warp bubble. I like it.
You'd actually be expanding space-time behind the ship and contracting it in front. This creates a wave that propels the bubble forward, and the spacecraft inside rides that wave.
So like riding a cosmic wave.
Kind of. NASA even created a visualization of this a while back. It's pretty incredible.
I bet.
Eh,
But I remember reading somewhere that the amount of energy needed to create a warp bubble would be astronomical.
Oh, yeah.
Like more than the energy of the entire universe.
Yeah, that was the initial problem.
Is that still the case?
Well, the idea was you'd need something called exotic energy, most likely negative energy, and a lot of it.
Right.
But the exciting part is that more recent calculations suggest those early estimates were way off.
Oh, really? So how much lower are we talking?
Well, some estimates have dropped the requirement from the energy of the entire universe to something closer to the mass energy of the Voyager spacecraft.
Wow, that is a huge difference.
It's huge.
So could warp drives actually be within our reach?
It's definitely a possibility worth exploring further.
I like the sound of that.
And this is where that concept of negative energy comes back into play. It might hold the key to making warp drives a reality.
So negative energy isn't just some theoretical idea, it actually exists.
There's a real measurable phenomenon called the Casimir effect that demonstrates negative energy density.
Okay, the Casimir effect.
It occurs between two very closely spaced, uncharged conducting plates.
Wait, so you're telling me there's a spot in the universe where the energy density is actually below zero just because there are two plates hanging out next to each other?
It sounds crazy, but that's exactly what the Casimir effect shows us.
Wow. Okay, my mind is officially blown.
It is a trip.
If we could figure out how to harness this Casimir effect to generate and control negative energy on a large scale, could that be the fuel for our warp drives?
That's the million-dollar question, isn't it?
It is.
And it brings us to a fascinating story about a man named David Pears.
Oh yes, David Pears, the former Air Force meteorologist and science professor who claims to have created a micro-warp drive prototype.
You know it.
Inspired by thunderstorms, that's dedication. Okay, I know this sounds wild, but what if he's onto something? What kind of evidence would convince the skeptics?
Well, Pears believes that thunderstorms generate incredibly powerful electrical fields, maybe even antimatter, which he thinks could be the key to manipulating space-time.
Interesting.
He claims to have achieved actual measurable physical displacement of objects using just a small amount of power around 100 watts.
Really?
Yeah, and get this, he even used his wife's croquet ball as a weight in his experiments.
Wow, using his wife's croquet ball. That's amazing.
It's a great story.
But I imagine the scientific community is a bit skeptical, right?
They are, and for good reason. Extraordinary claims require extraordinary evidence, and Pears's work hasn't been independently verified.
Right, of course.
But, I think Pears's story highlights something important. Innovative breakthroughs can come from the most unexpected places.
I love that it's a good reminder to never underestimate the power of curiosity and thinking outside the box.
Couldn't agree more.
But bending spacetime isn't the only way to achieve faster-than-light travel, right? What if we could create shortcuts through the cosmos itself?
You're talking about wormholes.
Exactly, wormhole.
Another science fiction staple that has a basis in real physics.
So instead of traveling vast distances through space, you could theoretically hop through a wormhole and instantly arrive at your destination.
That's the idea.
Amazing. Tell me more.
Well, like warp drives, wormholes would likely require exotic matter, potentially that same negative energy,
Right.
to keep them open and stable enough to travel through.
So this negative energy keeps popping up as a potential key to FTL travel, whether we're talking about warp drives or wormholes.
It seems that way.
It seems like everything hinges on figuring out how to harness it.
It might. And remember the Casimir effect we discussed earlier.
Yeah.
If we could understand and control that effect on a larger scale, it might unlock the ability to generate the negative energy needed for wormholes,
Yeah.
maybe even warp drives.
So it's a chain reaction of wild possibilities, all stemming from this strange but very real quantum phenomena.
It is pretty wild.
But we need to remember that science is all about rigor and verification.
Absolutely.
Has there ever been a time when the excitement over FTL possibilities led to, let's just say, a false start?
There has. Back in 2011, there was a lot of buzz about the Opera experiment in Italy.
I remember that.
They claimed to have measured neutrinos traveling faster than light.
Yeah.
It seemed like we were on the verge of rewriting physics textbooks.
So what happened?
Well, it turned out that the results were later found to be due to equipment errors.
Oh, no.
Yeah, a faulty fiber optic cable was throwing off the timing measurements.
So a good reminder that even the most careful experiments can be affected by unexpected problems.
You got it.
We've covered some pretty mind-blowing concepts already, but I know we're only just getting started.
We've just scratched the surface.
Where do we go from here?
I think it's a good place to pause for now.
Agreed. We'll continue our journey into the mind-bending possibilities of FTL travel in our next segment.
Welcome back to our deep dive into faster-than-light travel.
We've already explored some mind-bending concepts like warp drives, wormholes, and even the potential of negative energy.
And it's amazing to think that those concepts are rooted in real science. Not just science fiction, but as we continue our exploration.
Right.
It's important to remember that the pursuit of FTL travel isn't just about the physics and engineering, it's also about pushing the boundaries of what we think is possible.
Absolutely. And to really understand the implications of FTL travel, we need to step back and look at the bigger picture. You mentioned in your notes that you're fascinated by the philosophical implications of time travel. Well,
Oh yeah.
FTL travel opens up a whole can of worms in that department.
It really does. The potential impact on humanity is immense. Just imagine the possibilities exploring distant galaxies, encountering other civilizations. It would revolutionize our understanding of our place in the cosmos.
It's almost too much to comprehend.
I know, right?
But let's try to break it down. What would be some of the practical and philosophical challenges we'd face if FTL travel became a reality?
One of the biggest hurdles would be figuring out how to navigate the potential paradoxes that could arise from traveling faster than light.
Time travel paradoxes.
Exactly. We're talking about things like violating causality, potentially changing the past or the future. It challenges our fundamental understanding of how time works.
It's like those classic time travel paradoxes, like going back in time and accidentally preventing your own birth, except now we're not just talking about time travel, we're talking about manipulating space-time itself. That's heavy stuff.
It is. And these aren't just theoretical curiosities, they're questions we'd have to grapple with if we ever hope to harness the power of FTL travel.
So while the possibilities are exciting, the potential consequences are pretty daunting.
They are, but I still believe the potential rewards are too great to ignore the eye. The human spirit is driven by exploration, by the desire to push beyond known horizons, and if FTL travel is even remotely possible, I think we'll find a way to make it happen.
I agree, but it's not just about reaching distant stars, right? FTL travel could also revolutionize our understanding of physics, potentially opening up entirely new avenues of scientific inquiry.
It's like a domino effect of breakthroughs. One discovery leads to another, pushing the boundaries of knowledge further and further.
Okay, let's dive back into some of the more specific concepts we've touched on earlier. We talked about the L.P.C or warp drive. It's still a theoretical model, but it's based on some pretty solid physics, right?
It is. The idea is that you create a warp bubble around a spacecraft, expanding space-time behind it and contracting it in the front of it. essentially surfing on a wave of space-time.
Right. And as we mentioned, those early estimates about the energy requirements have been drastically revised.
They have.
And that's where negative energy comes in. It's this bizarre quantum phenomenon that we know exists because of the Casimir effect.
Yeah.
But harnessing it on the scale needed for a warp drive, that's another challenge altogether.
That's the challenge, but that's part of what makes this field so exciting. We're talking about pushing the very limits of our understanding of physics. And even if we never achieved FTL travel, the knowledge gained from exploring these possibilities will undoubtedly lead to other incredible discoveries.
You know, it reminds me of something Carl Sagan once said, somewhere something incredible is waiting to be known. And I think that perfectly captures the spirit of this deep dive. We're searching for the incredible, even if it lies beyond the realm of what we currently believe is possible.
I love that quote, and it's that spirit of exploration, of pushing beyond the boundaries that has driven human progress throughout history. Think about the early explorers who set sail across uncharted oceans, or the inventors who dared to dream of flying machines. They were all driven by a thirst for the unknown.
And who knows, maybe someday we'll look back on our current understanding of the universe and marvel at how limited it was, perhaps. FTL travel is just one of many incredible discoveries waiting to be made.
It's certainly possible. And speaking of pushing boundaries, let's circle back to David Pears, the former Air Force meteorologist who claims to have created a micro-warp drive prototype based on his observations of thunderstorms.
Yeah, his story is fascinating. I'm really curious about his process.
Well, he doesn't have access to the kind of equipment you'd find in a university physics lab, so his methods are unconventional, to say the least.
And his claims are extraordinary, which requires extraordinary evidence.
Right. But I admire his spirit of innovation. He isn't bound by the same constraints as traditional researchers. He's not afraid to experiment, to try things that others might dismiss as impossible.
Exactly. Even if his specific claims don't hold up to scrutiny, his approach, his willingness to think outside the box is something we should all admire.
It's a reminder that the path to scientific progress isn't always linear. Sometimes the most important discoveries come from the most unexpected sources.
And sometimes it's the people who are willing to challenge the status quo, who aren't afraid to be laughed at, who end up making the most significant contributions to human knowledge.
That's a great point, and it brings up another aspect of FTL travel that we haven't discussed yet, the ethical implications, if we ever do achieve FTL travel. It's not just about the technology, it's also about how we use that technology responsibly.
That's a crucial point. We need to consider the potential consequences of our actions, both intended and unintended.
Precisely. For example, if we were to encounter another civilization, how would we approach them? Would we be welcomed as explorers or feared as invaders? And what if that civilization had technology far beyond our own?
Those are some weighty questions, and there are no easy answers.
No, there aren't. But they're questions we need to start asking now before we stumble blindly into a future we're not prepared for.
It's like the old saying, with great power comes great responsibility, and the power to travel the vast distances of the cosmos at speeds faster than light would be one of the greatest powers humanity has ever possessed. It would be a game changer, and we need to be prepared for the challenges and opportunities that would come with it.
Absolutely. So as we continue our deep dive into the possibilities of FTL travel, let's remember that it's not just about the science and technology, it's also about who we are as a species and how we choose to use the knowledge we gain.
It's about understanding our place in the cosmos, pushing the boundaries of what we believe is possible, and doing it ethically and responsibly.
And ultimately, it's about the pursuit of knowledge, the curiosity that drives us to explore the universe and uncover its secrets. Speaking of uncovering secrets, are you ready to explore some even wilder concepts?
Absolutely. Bring on the mind-blowing possibilities.
Yeah.
Bring on those wilder concepts you mentioned. We've covered warp drives, wormholes, and even the potential of negative energy.
We have.
What else is there? What are the truly out there ideas when it comes to FTL travel?
Well, how about this? Some physicists believe the key to FTL travel might lie in the intersection of general relativity and quantum mechanics.
Hold on, those two don't exactly get along, do they? I thought they described the universe in completely different ways, like trying to mix oil and water.
That's exactly the problem.
Yeah.
They describe the universe in fundamentally different ways, and finding a way to unify them to create a theory of everything has been a goal for physicists for decades.
A theory of everything has a nice ring to it, but how does this connect to FTL travel?
Some physicists think that a deeper understanding of the quantum nature of space-time might reveal ways to manipulate gravity.
Okay.
And if we can control gravity, Who knows? Maybe we can even find a way to exceed the speed of light.
So instead of trying to force our way through space-time with a warp drive,
Right.
we might be able to find ways to exploit the quantum fabric of reality itself. Now you're talking my language.
Exactly. It's definitely a highly speculative area of research, but it has the potential to completely revolutionize our understanding of the universe and maybe even unlock the secrets of FTL travel.
It's almost like we're moving from engineering challenges to fundamental physics, where the very nature of reality is up for grabs. And speaking of fundamental physics, what about this idea I keep hearing about the possibility that our universe might not be the only one?
Multiple universes. The idea is that there could be an infinite number of universes, each with its own set of physical laws and constants.
Whoa, are we talking about parallel dimensions, alternate realities? Is this where we jump into the Marvel Cinematic Universe?
It's one way to think about it, and while it might seem like something out of science fiction, the concept of multiple universes is actually supported by some theoretical models in cosmology and quantum mechanics.
So maybe in some of those universes, the speed of light is different, or maybe FTL travel is as easy as hopping on a bus.
It's certainly possible. And while we're in the realm of speculation, it does make you wonder if other universes exist, could we ever reach them?
Yeah.
And would that be considered FTL travel?
It's mind-boggling, but it also highlights something we've seen throughout this deep dive. Every time we think we're getting close to understanding the universe, we uncover a whole new layer of mystery and wonder.
It's true. It just shows that science is a never-ending quest to unravel the secrets of the cosmos. And with each discovery, new questions and possibilities emerge. We've only scratched the surface of the possibilities. But I hope this deep dive is giving you a lot to think about.
It definitely has. We've journeyed from the theoretical foundations of warp drives to the mind-blowing realm of multiple universes. We've explored the challenges, the possibilities, the science fact, and the science fiction, and I think it's safe to say that faster than light travel is a topic that will continue to captivate our imaginations for a long time to come. So to wrap things up, what's the one thing you want our listener to take away from all of this?
I think the most important takeaway is this: never stop questioning, never stop exploring, and never stop wondering what lies beyond the limits of what we currently believe is possible. The pursuit of the impossible is often what leads to the most profound discoveries.
Beautifully said. Thanks for joining us on this incredible deep dive into the world of faster than light travel. Until next time, keep looking up and keep asking those big questions. There's a whole universe out there waiting to be explored.